Let's take a look at the solutions to part 1 of the exam 1 review. Remember, there are 2 parts. The second part has rate of change, sketching them, antiderivatives, integrals, initial value. Don't forget to do that one too. On this one thing to note, number 3, instead of x to the 7th here, because I'm not going to ask that high of a degree, just make that guy x squared. Okay, so for number 3, make that x squared. When we look at number 1, we're just being asked to find the derivative of this. When you look at this, we have variables in the denominators. Let's make them negative exponents. When you make them negative exponents, here, that's really just the function, no derivative yet. Now the derivative of this, power rule, bring that down to get negative 24, subtract 1, negative 5. Bring the negative 1 down, positive 9. Subtract 1, negative x2. So you can leave it like this, or you can rewrite it in fractions. The key is that whenever you see these variables in the denominators, always rewrite them to get a negative exponent. So that's this guy too. And the second one, you're not only doing that, you're being asked to find the tangent line, and the tangent line at this point. So rewrite this guy to get a negative 1. The slope is going to be the derivative evaluated at that point. So find the derivative, bring the negative down, subtract 1 to get a negative 2. We want to go ahead and evaluate it. You don't have to simplify, just throw that 3 in there. And so that's 3 to the negative 2, that makes 3 squared in the denominator, which gives you 9. That's just negative 5. So that's slope. And so tangent lines, you need slope and then you need the b. So we've got the slope is negative 5. We've got the point. Go find the b. This one is using a different formula, but you're still going to get the same b. So if you set this up equal y equals mx plus b and solve for b, you'll still get 30. Different path, same solution. We get a lot of that. And so for number 3, this is the one you rewrote to make this an x squared. And so for this one, you're just being asked to find out where the horizontal line is tangent. Yeah, is horizontal, sorry. And so here's our function. Rewrite the root. Remember, we can just make that a 1/2 because this is x to the first and it's a square root. So the 2 of the index goes here. Now take that derivative, you get 2x, 1/2 x to the negative 1/2. Well, when you look at this guy like this, and you're like, how am I ever going to know if this thing is equal to 0? Well, add that negative 2x to the other side, and you get this. Are either of these ever going to be 0? So can they be equal to each other? That's this guy, set it equal to 0. Bring them over, can they ever be equal to each other? And the answer is no. So there's no horizontal tangent line. This one's a little weirder, but you're going to run into that on MyLabs Plus once in a while. For number 4, given the function, find the points at which the graph has a tangent line of slope 1. So points where the tangent line has slope 1. Here's the function. Bigger, doesn't matter. We can still take the derivative. We want the first derivative to be equal to 1. That's what the slope means. So take this guy's derivative, power rule, power rule, power rule. This guy is a 0. Once you have that and you come down and simplify it, set it equal to 1. That's this y prime equal to 1 because we need the slope 1. You're going to set this guy equal to 1. Now bring the 1 over, quadratic, factor. You factor it, you use the 0 property to get 1 and 3. And then once you have them, you need to find the y values because it's asking you what points. So you have to take each of those x values and substitute it in to get a y value. So let's take a look at number 5. You've got the area of a circular oil spill, and it changes with the radius. At what rate does the area change? And say, with respect to that, that's when the radius is 10. So here's our area formula. The derivative of that is how the area is changing. And the area is changing when the radius is 10. So we get 20 pi. We wanted 8 prime of 10 because how the area is changing, that's derivative when the radius is 10. So it changes at 20 pi feet squared per foot. Now over number 6, just derivative, product rule. Remember, we took a look at this. We could either use the product rule on this guy or we can multiply them out. I went ahead and FOILed it. If you have the option of choosing, you really do have a choice. So FOIL it first, outside, inside last, and you get this guy. Then use the power rule to get the derivative. For number 7, you are writing the equation of a tangent line at the point of the graph where it has this value. So we need a tangent line at x is 0. It's a quotient rule, that's okay. P is the numerator, Q is the denominator. The derivative of the numerator is negative 4x. Derivative of the denominator is negative 3. Now we're just going to do P prime Q minus PQ prime over Q squared. That's the quotient rule formula. Just substitute it in. Remember, you don't have to simplify it here. We want to know what happens at x is 0, and we love that because the 0 knocks everybody out almost. So we get 0 times this, which is 0. And then 6 times negative 3, and then this negative gives you positive 18. Negative 2 squared is 4. 18 divided by 4 is 9 over 2, so that's the slope. Now remember, for number 7, we're also asked to get the equation, so you have to then go ahead and find the b, and once you have that b, you are able to get your then slope-intercept form. Now, when you are here, we're doing 0, where at x is 0, that is the y-intercept. That's why you can substitute. For the next one, number 8, is got a word problem where we've got men's suits. We have a cost function. Find the rate at which the average cost is changing. Average cost, notice average cost is the cost divided by x. That's the average cost. And so that's where that formula is coming from. That's why you divide by x. It's the average. And then quotient rule gets you all the way down to here. Once you have the quotient rule, you're asking the rate at which it's changing with 500. So you just substitute the 500 in. Now for this guy, it's asking you to round to 4 decimal places. So go out an extra one, write it down, then round in to get the average rate of change there per suit. Don't forget your sentence answer. Number 9, another word problem. You've got the population given as a function. So here it is. They're asking for the growth rate, and the growth rate is just the change in the function. So we need P prime. Use the quotient rule. Here's the quotient rule. Or you can go ahead and simplify it if you want, but unsimplified, which is what I'm asking for, just looks like this. Just leave them like that. For number 10, write an equation of the tangent line at the point of the graph where x has this indicated value. So we have a tangent line at x is 0, so we're going to look for the derivative and evaluate it at 0. Here's your function. I multiplied this out. Why use the product rule? And then go ahead and for each piece, you're going to take then the derivative of this piece and this. The derivative of 12 is 0. Here is my derivative, evaluated at 0 to get 25. Now you need to find the b, so go ahead and put 0 in. Remember, because when you have an xy plane at x is 0, that is the y-intercept. So you get 12, so we have this slope and intercept, and you're done. So we love it when they give us x is 0. It just simplifies it that much more. And then for number 11, another word problem. We have revenue. We're trying to find the rate at which the average revenue is changing. Average revenue, here is a notation for it. Average means divide by how many. So your function divided by how many. And go ahead and simplify that. Because you have an x here and here, you can't just divide out. It's easier to bring them up to make them a -1 and add them in. So here's your function. Take your derivative, it's power rule. Once you have that, find the average rate of change, find the derivative at 74, substitute the 74 in to this very ugly guy, use your calculator, and you end up with this. So the average revenue is dropping because it's negative by this much per bottle when 74 bottles are sold. So that's it. Hope you're having a great day.